everyone, I'm Eli. I'm a 17-year-old innovator who is currently studying artificial intelligence. Recently, I built a movie recommendation system that I thought would be cool to share. Before we get into the code, you should know a little bit about recommendation systems. There are two main types of recommendation systems: content-based filtering and collaborative filtering. Collaborative filtering is based on users, so it finds users that are similar to each other and recommends things that the similar users liked. Content filtering finds content similar to what you like and recommends that. The best recommendation systems usually use a mixture of both collaborative and content filtering. That's what I did, though I took a bit of the easy way out when I was combining them. But I did build both, so let's take a look. Okay, so let's get started by looking at my code. So I broke this up into three larger sections: getting the recommendations using singular value decomposition collaborative filtering, and then getting top 10 recommendations using content filtering, and then putting it all together. So let's start at the beginning. So for collaborative filtering, first I imported the modules I needed. I used several from Surprise, which is a library, that is built for collaborative filtering models. I also used random and then default, which is a slight twist on a dictionary that is very useful in certain situations. Then I just define my function that will give me the top 10 recommendations for each user. It will return a dictionary where the keys are user IDs and the values are a list of the top 10 recommended movie IDs. That way I don't get all of them ranked in order from largest to least, from most to least relevant. Then here I pre-process my data. Surprise is really useful because it has several built-in data sets, including the Movie Lens 1 million that I used. I then prepare the data set, which is really easy because it's already built in. I create and train the algorithm. I used, again, singular value decomposition. I used 30 epochs and regularization 0.03. Then I fit it to my train set. Nothing unusual here. And then I just find my predictions. I build my test set as build anti-test set is the function, which takes the training set and returns a set of users to predict their recommendations or their ratings for the values for the movies that they have not watched. So, for example, if user X has watched The Matrix and not watched anything else, this test set will find the value for X predicted for other things, but not for the prediction for X's rating for The Matrix, because X has already watched and rated it. Then I just put it through to get my predictions, and then use my function from up here to get my collaborative top recommendations. And I put collaborative because this is collaborative filtering. I'll also have content top recommendations, I believe. And then now getting into content filtering, there's a little more code because I did not have a library like Surprise that handled almost everything behind the scenes for me. So I imported the libraries, NumPy, Pandas, and then Counter and Simple Imputer. I loaded data so I had three files I used: Movies 1 million CSV, movie correct genome scores 1 million.csv, called correct because I had to alter some of the, because I named it, because I had to alter some of the data format. And then ratings.csv. So going back up here, I used Movies 1 million CSV. It provided a list of the movie IDs, a list of the movie titles, and a list of the movie genres. I then created a dictionary matching the IDs to their titles so that when my work returns the top recommended movie IDs, I can put them back into the titles so we can see them. Here, I simply list all the possible genres in order so that I can then encode genres. So for each movie, the movie ID will be a key in this dictionary, movie genres dict, and it will have the value will be a list of the possible genres length with a 1 for each genre that it is and the 0 for ones that it isn't. So for example, if I had an action movie, the first position or 0 position would be 1 and then all the others would be zeros. Coming down here, I finished manipulating that data for now, and so then I go to genome, correct genome scores 1 million, where I get the IDs, which is a duplicate list, hence movie IDs from tags, with enough IDs to match 1 for each tag relevance. The tag relevance, there's 1 for each tag in each movie, and it says how relevant that tag is to that movie. It's a score between 0 and 1. And then I put that data into a dictionary with the key being the tag ID and then the value being a list of all the tag relevances that were from that tag. And then I put the tag here. I put them for each movie into a dictionary with item format movie ID as the key, and then the relevances as the values in order. That way they can be easily compared. I also included this line, movie irrelevances, the name of the dummy list, .append 0.5. That's for if a value is missing, to simply put 0.5 for it. That way I don't run into issues with the lengths of my lists being off when I'm not expecting them to be. Here I import my third data, rating CSV, which contains user IDs, the movies they watched, and then the ratings they gave that movie. I convert that into lists because I find lists easier to work with. I then create a dictionary, yet another one, with form user ID as the key and list of movies that were either rated 3 or up, which is my metric of did they like the movie or not, as the value. That way I'm only recommending movies based on movies that they actually liked. So then here I create a master dictionary is what I called it, where each entry, the key is the movie ID and the list is a list of both the encoded genre values and the tag relevance values for that movie. That way it can all be compared very easily. Then down here is where I start getting into the specifics of the individual user. So here I picked X, the user, to have the ID 4026, and then I use X simply so that if I want to find a different user, say 321, I can simply change this and I don't have to go through everywhere and change it. Then here I simply find the top 10 recommendations specifically for user X from my collaborative top recommendations. I create a list of movies, all movies that user X liked, so that I took that from the all liked movies. And then here is where I find what I call long recommended movies for X, which is using each movie that X liked. I set up in a 2 4s and several ifs and elists to form a list of the top 5 movie IDs, or which are the movie IDs that are most similar to that movie. So there will be 5 returned for each movie, and then that is appended to long recommended movies for X. Finally, because say X likes 20 movies, then that would give you a list of 100 recommended movies, which is way too long. So I use Counter to find the movies that are most repeated on that list, the 10 most repeated, and simply use that for user X content recommendations. And then I put it all together. I find top recommended movies, if there are any, which are ones that are recommended both by collaborative filtering and content filtering, and then simply recommended movies, the ones that are recommended by either collaborative filtering or content filtering. So here I have the for loop that gets the collaborative movies into a set and changes the recommendations into integers from here. Here I
put the content movies and then change that into a set so that I can then use the intersection function, or intersection method, which finds the values that are in both sets to find the top recommended movie IDs, and then the symmetric difference, which finds the ones that are in one or the other set to find recommended movie IDs. I then convert the movie IDs into titles so that we're not just getting a list of numbers, which are meaningless to us humans, but actually titles that we can recognize. And then I print them. And below here will be the results for user 4026. But first, let's take a look at what movies that user liked so that we can see if it makes sense. So here I simply printed all the movies liked by user 4026. I copied the vast majority of the code from Hybrid Movie Recommendation. Here I imported libraries that I needed, pandas, numpy, and then default dict. I load data from rating CSV, convert it to lists, and then create a dictionary, user ID, list of movies the user rated 3 or up, so the all liked movies. Load data from movies 1 million to get the IDs and the titles, and then match the movie IDs to their titles. Here I simply state the user, again so that I can easily change the user number without having to go through the whole thing. And then here I simply find the specific movies that are liked by that user and print the IDs just to make sure everything was working. So long list of numbers, probably meaningless to you, definitely meaningless to me. Then I convert them to movie titles, which are less meaningless, and then I print them. So let's take a look. This user liked a lot of movies, so let's see. Christmas Story, Interview with the Vampire, Boiling Point, Emma, Stand By Me, Blade Runner, Clockwork Orange, a lot. I have not seen the vast majority of these, so I really don't know what they're about. But if there are users out there who like some of these movies, perhaps you can then look at the movie recommendations and see what if it works. And then we can go back here and see the recommended movies. Schindler's List, Bicycle Thief, River Runs Through It, Max Dugan Returns, One Flew Over the Cuckoo's Nest, Usual Suspects, Shawshank Redemption, Soft Fruit, Sanjuro, Absent-Minded Professor, Touch of Evil, Seven Samurai, The Magnificent Seven, Shin no Samurai. That might be a different language, I don't know, and I'm sorry if I butchered it. Any Given Sunday, Under the Rainbow, Stacy's Nights, Crow, Salvation, Kid, Taxi Driver, Blackbeard's Ghost, and Night on Earth. So I hope these are reasonably accurate. The movie dataset was compiled in 2003, I believe, so none of these are recent movies. So I hope you really enjoyed that code. I know I enjoyed building it and then going over it with you. If you want to learn more about recommendation systems, which I'm sure you do now, check out my article, How to Build a Recommendation System, which I will link in the description. It takes a technical look at both content-based and collaborative-based filtering. And if you like this video, like and subscribe. And if you want to connect with me, you can connect with me on LinkedIn or subscribe to my monthly newsletter for updates on my progress. See you guys next time.